Hello, Year 11. Well, it's Mr. Mumford is now back in his shed again for another week. Yippee doo-dums. Anyway, I'll keep going, and hopefully you're having a teacher teaching us at school on Monday. But I thought I'd put this on Edimodo to help you do this equation. It's constant acceleration equation. It's a bit of a pig, I'm afraid. We need to do it A-level, but they decided to put it in GCSE. And what I want to do is a little video is show you how I use the constant acceleration equation. It's very good, actually, in some respects, to working out lengths and runways of aeroplanes. Anyway, now a little bit of practical we're done with you, involving a little cart going down a hill. But unfortunately, due to the fact of me not being there and practical work being very difficult at the moment, I'm afraid I've not done it. Anyway, so yeah, here it is. It is given to you in exam. Do not panic. So it is a given, and you should be writing it down in your book, and hopefully you've done that today in class, or you're doing it at home. You can write in your book now. Now, it looks horrendous, doesn't it? But it's not. Okay, now there's a group of these equations, and if you would like to carry on further in physics, which I hope some of you will do, in year 12 you will meet more of them, and they'll come dead easy. Really are easy, but at this stage it's difficult because you look at that and think, what the heck is it? Well, it's not too bad. Okay, V you met before. V is going to be a final speed. U is going to be the initial speed. And some of you then thinking, oh, what the rest of symbols mean, aren't you? I know, isn't it exciting? What do you think A is? It's going to be acceleration. I think you could have guessed that one. And one you would not have guessed so easily is S. It is going to be distance. I have used S as distance before. But the important thing is that's what you measured in meters per second. Initial speed is also going to be meters per second. Acceleration is going to be meters per second squared. And then distance is going to be S. So, how do I use it? Well, is it serious? If you ever go to Kathmandu, which is middle of Himalayas, there is basically a runway there, and where the runway ends is a massive cliff. And as the aeroplane comes in to land this runway, they basically will know the deceleration, that A, and they know the speed is coming in, and obviously it wants to stop, so your final speed is going to be 0. And believe it or not, they know roughly, they will make the length of the runway, and they put a bit of an error in here and make it a bit longer, it should be, to make it correct. Because they know roughly what the maximum deceleration can be to stop the whole thing falling off the edge of the cliff. I'll try and find a picture for you sometime, but it's a really cool picture. It doesn't exist as runway in Himalayas, believe it or not. Anyway, so here we go. Here's an example. An aeroplane is about to take off, accelerates along a runway at 2.5 meters per second. If it takes off at a speed of 60 meters per second, calculate the minimum length of the runway. So only the aeroplane actually landing. It also needs to know how long the runway needs to be for it to take off. So here's the equation. V equals u squared plus 2as. Okay, now what I've always done, I've told you to do, it's like a little shopping list, isn't it? Okay, write down everything they give you. V-U-A-S. So the final speed, aeroplane's about to take off and accelerates runway at 2 meters per second. It takes off at a speed of 60. So I know then the final speed is going to be 60. Okay? Now, if it's going to take off, isn't the initial speed going to be 0? Yes? Now, the acceleration gives me at 2.5 meters per second squared. And it wants the length of the runway. That is my unknown. And, oh yeah, I can see my calculator now. I can need it in a minute. So, what you do is you bung your numbers into equation. You then do 60 squared. Final speed is going to be 0 squared. Then I normally bracket this. It's going to be 2 multiplied by acceleration is 2.5 multiplied by s, which is going to be here the unknown. Now, we all know that 60 squared, 6 sixes are 36, then you put your 0 and another 0 on. It's going to be 3,600, isn't it? 2 times 2.5 is then going to be 5s. You then put that in your calculator. Do 3,600 divided by your 5. It's going to be, is it 70 odd? Yep, you get 720. And then your S is equal to 720 meters. Okay? I know it's very weird to this equation, but all you're doing is putting numbers into equation and you pop out an answer and it works lovely. And yeah, this will be top end grade 7, grade 8, this stuff. And it won't mean a lot to this equation at the moment, but I'll prove to you where it comes from in year 12 if you carry on with me. And it's a way of accessing higher grade by putting numbers into equation. The other one going here, give you another example. A ball is dropped. So you take this ball. It's dropped from rest. It then falls down. It falls down a distance of 8 meters. What speed just before it hits the ground, which is going to be here, which is going to be that final speed. So again, we've got acceleration of gravity. This time is given to 10. So use the value they give me. So this is the equation we want to use. V equals u squared plus 2as. Okay, you do your shopping list. V, u, a, s. So here we go. Final speed is the unknown. So I'm going to call that v meters per second. I want to know what it is. Initial speed, well, if I drop it, isn't the initial speed going to be 0 because it's starting from 0? Acceleration is going to be 10 meters per second squared. And the distance is going to be 8 meters. And you must make sure that distance is in meters. Okay? Then you put it into equation. V squared equals u, which is going to be 0 squared. Open up your brackets. 2 multiplied by 10 multiplied by 8. Okay? Therefore, your v squared is then equal to 20 times 6 is then going to be 160. Your v then, oops, that went completely the wrong place. Try that again. Your v then is going to equal to root 160. Put that in your calculator. Root 160, calculator don't fall on the floor, is going to be 12.649. So then you get your 12.649 meters per second, but don't quote it at number of decimal places, because here I would actually be happy with that to write down 12.6 meters per second. Okay, hope that's helped you. That is basically the constant of speed equation. Looking forward to see you all soon. I shall return. Bye for now.